Grade 11 and grade 12. Grade 11 in term 3, you'll come across this. Grade 12, term 2, you come across this one. Right. Calculate. The question was say calculate. Okay. Took it from Pumalanga paper, I suppose. Oh, okay. Yes. So I said, they say calculate the pH of 0.2 mole per cubic decimeter KOH solution. Assume that the KOH dissociates completely in distilled water for 6 marks. I'm giving you this plaque. Check. It is very simple to do pH. Remember, I said to calculate the pH of an acid, you use what? Chop. So you chop the acid. But to calculate the pH of a base, you use cook. You cook the base. So you cook the base. So what are we saying? You chop the acid, you cook the base. Chop, I've already done it. I have already done a video on chopping, right? Now let's follow this method. Now what am I saying? Um, this means this is the concentration of right, right. So this is the concentration of the base. This is the concentration of the base itself. Now, this part is the concentration of the OH minus. Since in a base we have got OH minuses, right? A base produces OH minuses. K is for KW, which is this formula here, the KW formula here at the bottom, right? Which is then P is the pH now. pH, now you come to this formula and you actually perform your pH calculation, right? So acid, you chop the acid, but you cook the base. You cook the base. You cook the base, right? So let's follow it. 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 Now. Right. So what are we given? We are given the concentration. Okay. We're given the concentration. The concentration 0.2 mole per cubic decimeter of the what? Of the base, which is KOH. Of the base KOH is our strong base. Okay. All right. Now, after that we must come to what? To concentration of OH minuses, and you are simply doing a ratio. So we're saying KOH is to OH minus. Now you must ask yourself, this is one base. In one base, how many OH do we have? How many OH do we have inside this? This is one base. And in this one base here, how many OHs do we have? We only have one OH, right? So the ratio is 1:1, which means if the concentration of the base is 0.2, then also the concentration of the OH minus is 0.2 as well. So we have got the concentration now. See, concentration of OH minus is 0.2 mole per cubic decimeters. Right? We got that concentration. Right. We got it. Concentration of OH minus is equals to 0.2 because the ratio was 1:1. Right, this should be a square bracket. The square bracket means concentration. Okay, now after that we must go to KW formula. Here is our KW formula. What does it say? It says KW is equals to the concentration of hydronium ions multiplied by the concentration of OH minus, yes, is equals to 1 times 10 to the power negative 14. Right? Now we do substitution, right? Then we say concentration of hydronium ions. Then I substitute the concentration of the OH minus 1 times 10 to the power negative 14. Right? Then you divide both sides. Now you divide both sides. Divide both sides by 0,2. Divide by 0,2. Note that when I substitute this value of concentration, I'm using round brackets. But this I'm using square brackets, which means concentration. Right? Divide both sides. Divide both sides. Right? So if you do that, if you divide both sides, then the concentration of hydronium ions will be equals to 5 times 10 to the power negative 14 watt mole. You write your units per cubic decimeter. Per cubic decimeters. Mole per cubic decimeter. Yes. All right. Now we got the constant. We have used kW. Now we come to what? To pH. Come to pH. I now start and say now the pH is equals to negative log concentration of what? Hydronium ions. Right? Now negative log, what is the concentration? 5 times 10 to the power negative 40, right? And the answer will be 13,3. And it makes sense that the pH of a base is greater than 7. And that's how we actually do it.